Okay, we've just discovered that there are 15 nickels here, and at this point we could use Cramer's rule just as we did to find nickels, find d sub d and d sub q, but at this point it looks like it might be a better idea to just look at two of these equations. Those are the easiest ones. Substituting n equals 15 into those will result in two much easier to solve linear equations with two variables. So if I plug n equals 15 into these equations, I have 15 plus d plus q equals 48. And I can take 15 away from both sides of that. So this equation becomes d plus q equals 48 minus 15 is 33. So that's a much improved little equation. Let's plug n into, so we're going to use this one in a second here. So let's plug into the second equation there, n equals 15, and it becomes 15 plus 2d plus 5q equals 144. And if we take 15 away from both sides of this one, we end up with 2d plus 5q adds up to 144 minus 15. That's 129. So that'll be our second little equation. So to solve this system, we can really now just solve the linear system d plus q equals 33, and 2d plus 5q is equal to 129. So this will become our new linear system to solve. To solve this linear system, we'll use Cramer's rule again. So our new d, this is our new improved determinant, not the same as that one. 1, 2, 1, 5. So this is going to be 5 times 1, which is 5, minus 2 times 1, which is 2. So this one equals 3. D sub d means we cover the d column with 33 and 129, but the q column remains as it was. And so this determinant is 33 times 5, which is 165, minus 129 times 1 is 129. So that was 33 times 5 is 165. 129 times 1 is 129. And 165 minus 129 is 36. 36. So therefore, we know that the number of dimes is this d sub d divided by d. That's 36 divided by 3. And 3 goes into 36 12 times. So we now know that there are 12 dimes. 12 dimes and 15 nickels. Well, now we can finish this one off because d plus q add up to 33. So d plus q equals 33, but d we know is 12, so 12 plus q equals 33. And if we take away 12 from both sides, we've found that q is equal to 33 minus 12 is 21. So we know there's 21 quarters. To summarize, we found that there are 15 nickels, 12 dimes, and 21 quarters. That's how many of each coin there are for this problem.